How did generative AI get so good so quickly? Are we approaching a performance plateau, or is the best yet to come? And will we see an AI Oscars category in the near future? My guest today is Matthias Niessner, a professor at the Technical University of Munich and an entrepreneur. Among his best-known work is that on facial reenactment, which started the global discussion around deepfakes almost a decade ago. Beyond academia, he co-founded the artificial intelligence company Synthesia, which specializes in AI avatars and synthetic media creation. Given the rapid advancements in generative AI in the recent years, it was really fascinating to talk to someone who was at the very forefront of this development. I hope you end up finding this conversation as insightful as I did. First, I'd like to show you something. I think this became sort of a benchmark for video generative models, namely Will Smith eating spaghetti. So this is the first version, right? This was posted to Reddit back in 2023, I think, so almost 3 years ago. And now with Google's VO3 coming out, this is more or less how it looks like. So could you please tell me how it's possible that it got so much better in such a short time?
Yeah, I mean, so when we're talking about, well, let's call it generative AI in general first, right? So we're gonna have multiple domains. We're gonna have text, images, and videos. And I would say when the big moment for images was basically when Stable Diffusion came out. So when the people around Robin Rombach, Andreas Plattner, these guys, um, they developed this latent diffusion work where basically you could go ahead and for the first time create images at a very high resolution that essentially looked like real images.
Okay.
And the way they did this, they basically developed a new method which made it more scalable to train. So they basically had this diffusion idea. They made it more scalable with a couple of tricks such that you could throw more compute at it and more data at it. Suddenly, with more data, it got better. Before that was not the case. Before, people were mostly using GANs, like generative adversarial networks, that they produced something on smaller cases like faces or individual objects, but they never were able to get these scaling laws that you see in modern AI tools, where you throw more data at it, bigger architectures, and so on. So the images was basically first.
Okay.
So making this work. So Stable Diffusion was the big breakthrough on that side. And that drew a lot of attention. There were like, Reddit's, entire subreddits dedicated to it and playing around with it. And the way they made this work basically at the time was they had this research paper called Latent Diffusion, and they collaborated with Stability AI. There was a startup, they raised some funding, and they gave these quote unquote poor students, they gave them, I think, $500K at the time. And they showed this worked great. And they realized if they gave them more dollars, suddenly the stuff worked better. And for like visual generative AI, like basically images and video generation, that was kind of a very defining moment, because suddenly you could basically trade quality for compute, right? So you get more compute, you get more data, and you can scale it up and get more stuff out of it.
And this is where most of the money went to compute, or how did they spend it?
Well, I always like to call it ML infra. Compute is always like, you would argue, oh, it's just GPUs, it's just like raw computational power. But it is a little bit more, actually, right? It's also, you have to manage all your data, you have to process all your data, um, and that building this infrastructure required also very specific skill sets how to do it, right? You needed not just like the researcher who knows theoretically how it works, but you need to figure out stuff like how to train on like hundreds, potentially thousands of GPUs in parallel. And this is not so easy. Like, imagine one of your node goes down, you need a scheduling system that handles that. Nowadays, like a few years later, this is a lot easier. The tool supported. But at this time, it was not so straightforward yet. And so a lot of money goes into this entire infrastructure around it. Obviously, the researchers, they're also not that cheap either, right? I mean, they're making a pretty good living. But this is basically, you could scale up ML infra, meaning data processing, and compute for training, in order to get better results. This was a thing that the diffusion models basically enabled for visual data.
And how did those early models acquire their data that was necessary for the training?
So there's a data set called Lion. It's actually a public data set. And that one had a couple of billion of images. There's a couple of versions of it, like there's a Lion 5B, there's a large, smaller one. There's a couple of different subsets of it people had been using. And these data sets basically were images plus captions. So they had some text to it. And turns out like this relationship between text and images, that is very key towards training these models because it gives you more training signal to scale this stuff up faster. And then, yeah, getting back to the actual question about how you do the video stuff, right? At the time when this came out, people thought, oh, for images, this is great, but we spend so much compute on it, and we never can ever get good videos out of it, right? Everybody said, oh, yeah, okay, for one image, this works. It's kind of cute. It's neat. But for videos, it's much harder because you have multiple frames at the same time. So the amount of pixels you have to generate is just a significant larger number, right? And that was basically totally wrong, right? Like what turns out is it turns out you can scale it more. And fundamentally, there were a few technical ideas, but at the high level, it was just better engineering around the infra. So people managed to spend even more money on compute and on more money on infra, and they figured out how to scale this up such that you can process multiple frames at the time. And this example, what you've just shown, like, you know, the Will Smith benchmark of computer vision, so to say, is that the early versions were already pretty good compared to what everybody else had. Even the simple video you just shown, like people were actually amazed in 2023 when the stuff came out because it was not considered that AI could even do that. And then, you know, like it turned out that, you know, quote unquote, investing more effort again with more compute and more scalable architectures, it turned out you can make it better. It didn't get better overnight. I mean, there's a few like defining moments that came out, like obviously Veo was very impressive. But there's other ones, right? There's a lot of Chinese models actually that came out, like Kling was pretty popular at the time.
Oh, really? I didn't know this. So speaking about those like crucial milestones, so could you name them? So what are the most crucial milestones that got us here where we are now in the current state of generative models? What would you consider to be the most important milestones?
Well, I would start even a bit earlier, right? I would say the first Goodfellow paper on GANs was probably, I think it was 2013, if I'm getting this correct. Then I would say like 2019-ish when StalGAN came out. This was like the first, you know, adversarial networks that could produce high resolution images larger than a few. Well, it could go to over a megapixel at the time.
Adversarial networks. Could you maybe explain this a bit more?
Yeah, so adversarial networks is what came before diffusion, which was like what they did is they basically had, you know, two entities in a network. One of them tries to generate you something and the other one tells you how good it is or how bad it is. It's like this discriminator notion. And this is why it's called generative adversarial networks. They kind of compete against each other and they help each other to get better. And as you train more and more, you eventually getting better results. At least that's the theory. And this was kind of a very cute idea because it was not just an optimization. It was more like a gaming theory thing. It's like playing a game against each other, and as you play longer, in a sense, you get better. And it turned out though that this is not so easy to scale, and this is why diffusion eventually take over. Whereas diffusion was this I can maybe explain that a little bit, right? What diffusion is doing is you kind of have an image, you adding noise to this image, and eventually there's just noise left. It's like this like iterative application of noise, and the idea is instead of now predicting from noise to the image, what you do is you just predict every small little step. And it turns out it's easier to gradually go from noise to an image. So this is what networks can do better than just predicting an image in one shot.
Seems very counterintuitive for me as a human, not an AI, to be able to produce seemingly something out of pure noise.
Well, the idea is you're not producing everything in one step, right? The idea is you're producing a little bit out of noise, and then a little bit more and a little bit more. So there's like kind of this hand holding. So hold you how to draw an image in a sense, on a very high level. This is kind of the idea between diffusion, and this process turns out to be much easier to scale than the generative adversarial networks I mentioned before. So if you're talking about the defining moments, we had these GANs, we had these style GANs that made it work better. And then there was diffusion models coming out in parallel, kind of, but they didn't quite work yet. And then there was this famous latent diffusion paper by Rombach and these folks. that eventually made the Stable Diffusion. I think this was 2021-ish, plus minus. I mean, they had a bit of development time, but until everything worked right. And then I would say it's actually harder to have one specific defining moment anymore, because until this happened, so after this happened, everybody rushed into this. Like there were so many people rushing into it at the same time. So you could basically, whoever you're gonna ask, they're gonna tell you different milestones in a sense. So image models was a big thing. I would say another big milestone was when people changed the architecture all to transformer architectures. We can talk about this later, right? What is a transformer? So there was a time when these transformers, the very specific neural network architecture, took over as part of the generative process. But then there were probably by now hundreds of different models coming out, and each of them was a little bit better than the previous ones, right? They made it a little bit more scalable. For videos, the first models with like Will Smith eating spaghetti or so was very poor still at the time, but it was good enough to create enough inspiration that people thought, oh, if I scale this up further, I'm gonna get better videos. And this is still in this process we are still today. So today we are nowhere near towards, let's say, make a full Hollywood movie. We are still very far away. And probably if you ask a lot of people, even today, they're gonna tell you this is never gonna work in a movie. It's the same thing what people told everybody you can't create a single video at the time, like a few years ago. So, and I think we're gonna see more and more incremental progress, but sometimes this catches virality on the internet. So you see like one thing that just came out, right? But in practice, there have been many, many iterations actually in between.
Really, speaking about movies, like I think just a week ago, Matthew McConaughey went to the University of Texas. He said that he believes that in the future we're gonna have an Oscar category for AI generated movies. What do you think about that? Could this be a possibility?
Not so sure about that, to be honest. And the reason why I don't think so is because I believe almost every movie will have some AI in it. So I see it more like, so maybe let's rewind a little bit how movies are being made, right? So traditionally, for a movie, you have a camera, you have an actor, and your actor does something and record it, and then that's your movie. Um, but but it's not quite true, right? Like even in the 80s already, people started using computer graphics to do a lot of stuff synthetic. They had a lot of post-processing on the movies. And with time, more and more special effects were computer generated, right? Like and that was not a thing that AI invented. This was a thing before. You had like a lot of 3D artists they figured out to make some virtual worlds, and then you created virtually stuff around it. It's just cheaper to create an explosion virtually than to, spend millions of dollars to blow up a car.
Yeah, and also you can do it multiple times if it doesn't work
Yeah, and
out.
if it doesn't work, you try it again, right? And it's not a one-time thing. And so that in itself, I don't think is a new idea. The thing what AI has been enabled now, the point is this is just gonna be a lot easier, right? You don't need to spend like, I don't know, a month and maybe even years of creating virtual environments by hand, by like having a 3D artist and model the stuff and create a virtual world. Instead, you're gonna have an AI, you have a prompt, and it's gonna generate the output, or it's gonna modify the output of an existing movie. And to your question, do we have an AI category? So there has always been technical Oscars. So technical Oscars have been a thing. So people basically they awarded the technical capabilities of things like special effects, simulation stuff like that, and so on. And for instance, here at TUM we have Professor Tura here. He actually won an Academy Award.
Really?
Yeah, for simulation software that did and was widely used in movies.
I had no idea about this.
And this is something that I believe will go on for AI as well. I mean, there might be a special category calling, AI effects or something like this, or maybe it's just going to merge with the other one. But it's very clear that there will be parts of movies that will be AI generated. I'm not saying everything right now, but there will be definitely parts of it. And if you're going, fast forward in 10 years, pretty much every movie will have that. So that's why I don't believe there will be I don't think there will be a distinction anymore whether there's a movie just out of AI or a real movie. I think there's going to be a mix of everything.
All right.
And the further you go, I think the more AI is going to be used.
I just wonder, or maybe they have already figured it out. How do they make sure that the context is kept between the different generations, because what I saw most of the time is, okay, the camera turns a bit, turns back around, and we are in a completely different room, or maybe the character is wearing different clothes.
Right. So the people in the AI field call this the context problem. So whenever you're doing some generative AI, the way it works is you kind of have different pieces of your content you want to generate. So for text, this is typically a token. It's what ChatGPT does, for instance, when you generate text, right? You structure your text in tokens, and what's going to happen is whenever you generate a new token, it has to figure out what have you generated before to figure out what it has to generate next. And the same thing for video, right? Like you basically, the next frame you generate or the next n frames you generate, they will be dependent on the previous frames. And the more you generate, right, the more frames it has to take into account. And that gets harder the more you're generating at the end of the day. And this is why people have various kind of hacks how to deal with it. So some people say, well, don't look at every previous frame, just take a bunch of frames, then we can have larger windows and so on. So there's a lot of research how to do that, and it's technically quite complicated. But the bottom line is eventually you can only look at a certain part in the past because your models cannot they basically grow bigger. They need more memory to do that kind of stuff. And so, they hack around it, and the result in the videos is basically they're not perfectly consistent with everything they have done in the past. And I think that's a structural issue right now, how these models work, because basically they're generating still pixel by pixel. And that's the pixel based, or like some people use latent representations, but it's basically pixel by pixel. And what these guys are doing is they're just generating frame by frame. And I think that's a very inefficient way to do that. Right? I think a better way is to kind of figure out between frames, which are the pieces that are shared. Like, for instance, your background, your walls and stuff like this, they don't have the same environment, right? You don't want to regenerate them. You want to kind of cache that and reuse it. And this is where a lot of spatial AI models are coming into play right now. So in this case, you can kind of cache the stuff you've done already. You have the spatial memory. And then you can potentially have much more complicated environments for movies you can generate. While when you move your camera left and then go right again, you will see the same stuff again, and it's not going to move away, right? And this is how I think people are going to step by step resolve this whole context problem.
All right. And how long have you already been working on AI models or machine learning in general?
Yeah, that's a good question. What do you define as AI and machine learning? So I'm originally actually a graphics guy. So I started in my PhD. I worked a lot with Pixar and Microsoft, and we were working on making the movie content, making it easier for people to render in real time. So, for instance, when we worked with Pixar, we worked on making the Toy Story content at the time much faster to be rendered on a commodity PC. And some of these works basically made it actually into video games. Like, for instance, some of the stuff made in Call of Duty, they used it for um, for creating high fidelity geometry, basically, when they rendered the game levels and stuff like this. And to me at the time, it was very clear the hard part of this whole game is gonna be how to create the 3D content around it, right? The whole game level design, the character design, and so on. And what I did is I thought, well, okay, I mean, maybe we just don't model it by hand. We just capture it from reality. So I'm just going to take a bunch of photos of my room, right? And I have a virtual room, and I use that one. So I started working on 3D reconstruction afterwards. So that was mainly driven when the Microsoft Kinect came out. And that one was cool. It has like a depth sensor, right? You could basically capture environment in real time. You get a 3D world out of it. But it didn't really look that great. So it was fun for some stuff, like robotics folks. They loved using that, but it was never good enough for gaming, and it's still hard to do it today, even, right? But and then I realized, okay, like this capturing something is so difficult to do. You want to more have a generative process, like more do kind of the same thing what an artist is doing for a 3D game level. You want to have an AI do that. And this was very gradual. It was not like, oh, we just now be using AI. It was already for the reconstruction stuff. We used AI, how to make the reconstruction better, more visually appealing, geometry sharper. All these things already had deep learning in it. And then it got just AI got just more mature, right? At the beginning, it was like a simple neural network. It it did a bunch of stuff to your scan, whereas nowadays you can kind of create a whole 3D environment almost from scratch, and you just have a text prompt, get a 3D world out of it, basically. And yeah, this was also very, very, I would say, locally it always is incremental, but on the outside it often looks like, oh, there was this big breakthrough, but it's not always the case, I think. I think it required a lot of research over years. Um, and one thing we worked a lot was actually faces at the time. So we made a lot of stuff on face generation, meaning that, I take a video of you and then I create an avatar out of you. And that was very successful, like even like 9 years ago or so, or 8, 9 years ago. We made very good progress. And this was at the beginning was also more kind of traditional computer graphics, but then it turned very quickly into fully fledged big AI models, and nowadays like big diffusion transformers and so on.
You led right into my next question, actually, because I saw 9 years ago, on March of 2016, you posted a video to your YouTube channel, face to face, real time face capture and reenactment of RGB videos. For the people who might have not seen the video, could you maybe explain a bit what was happening there?
Yeah, so face to face was kind of a research paper where you could take a video and animate the person's face in real time. So I could capture a video of you and I could make your face move as if I could control it. So you kind of have like you become kind of my avatar, right? I could go ahead and pretend that you're doing something in the video with your face based on the control input that I'm giving you. And that one had a lot of interesting applications, right? So you could basically now create virtual videos of people appearing to say different stuff what they actually didn't do. And I define this as kind of an early version of a virtual avatar, right? I have kind of a video of you, and I can use this kind of video avatar to kind of explain stuff. For instance, it's kind of, think about it at the movies sample we had before, right? Like it was not a full movie, of course, but it was just the person in there, but I could kind of control the character to a certain degree.
Given how popular that video was, I think it's also a great time capsule for what the general public thought of it. And I have some comments here from the video that I'd like to maybe read to you, and maybe you could tell me what do you think about it, what has changed since then. So one person wrote, "Imagine the potential this has to the movie industry, notably the dubbing of other languages. The possibilities are endless."
Yeah, this was actually what we thought too. We thought dubbing was a pretty big application, we thought. And it was more interesting because I was at Stanford at the time as a visiting professor, and I'm native German, and I love watching movies. It's great. And I realized when you watching a movie in the native language, which for Hollywood is English, and then you dub it to German, the lip sync just doesn't add up. And once you've seen this actually, and you watched a lot of movies in English, and then you go back to German, it just feels very off. If you're used to it, you don't notice it that much. But once you experience the native dubbing, then you notice this immediately, and you just see, oh darn, the lip sync is so off, it just doesn't fit at all. And we thought, well, this is exactly what we want to do. We want to go ahead and take every movie on the internet and pretty much lip sync it to the respective target language. And we wanted to go further. We also wanted to do the translation automatically, right? The voice generation, everything else. So we wanted to go ahead and pretty much translate these videos into every language automatically using the latest technology we had done.
Mm. Another person wrote, "This can be very dangerous in the wrong hands."
Yeah, obviously this was also kind of a bit the birth of the whole like deepfake discussion, which I think got credited to this paper to a reasonable level. Um, that one I think is definitely true, right? You have to be careful whenever you can generate synthetic data. This was true 9 years ago, and it's true today. When you have generative methods, you have to be very clear on that people can mistake it for something real, right? I mean, so you have to be careful how you do this stuff. However, in principle, it's nothing else than just making a movie easier, right? It's just like, if I record you, you can say whatever you want. I don't know if it's true what you're saying, but you can make stuff up. If an actor does this or a news broadcaster does this on TV, they can also say whatever they want. It's like the video is real, but the content and information might not be. So I think actually it's a good development that we generally in the public questioning that everything we are seeing might not be real. And this was just one part of it at the time, but I think if you're extrapolating right now, um, ironically speaking, if you're going on the majority of social media networks right now, the majority of the content is kind of AI generated at the moment, right? I mean, Facebook is probably the worst example out of all of them. And I think people got used to it, that what they're seeing there is just fake. And I think in a sense that's a positive development, because I think it makes people less easy to be fooled, because they know, oh, they have they have a good question of what they can look at, is it real or not? And I think that's a good development that we are aware of it. But I do think that the positive applications, in a sense, what you could do with it, are just so vastly superior, and there's so many more. And I told that people to that at the same time when we brought this out, and we got a lot of agreement on that, and it turned out to be true, because there's a lot of commercial applications that are quite positive around it.
Okay, and speaking of people getting fooled by AI, do you remember the first time when you mistaken something that was AI generated for real content?
I remember a very famous video. I think it was posted online. It was a TV interview. It was around 1992 when Photoshop came out. So when Photoshop came out, everybody said, it's so over. Everything you're seeing, you can't trust anymore, right? And this same statement has appeared every single time a new generative technology came out. Can let it be a graphics thing that was hand modeled and stuff, or let it be eye model and stuff like this. And that is a thing that always was, people kind of got always scared when new technology came out. That's a general thing. It's a general sentiment. And I think it's important to be very transparent about it, explain what the dangers are, and then you can see what you can do about it. And to your question, when there was any video that was ever being mistaken for true in AI space, it's hard to say, right? Because I think this is a problem way earlier. Like making fake photos was like a thing in the 1800s already. Actually, it was interesting when the first photos came out. People started to edit it, right? They used it for propaganda and all the wars what we had in the last century, basically. And there's a lot of famous photos where, you know, um, people took photos and then they had a political companion and they removed that companion. Um, and yeah, so there's a lot of these ones actually. I don't want to go into all the details there, but I think this is always a momentary capture of society when they see that and they want to attribute it to something. When this was a big discussion recently with face to face was obviously in the 2016 presidential election in the US, right? Because this was like, you know, there were no limits anymore of what people could claim, basically, right? But it turned out it was not such a dominant problem for actually creating the fakes, because it was still too costly compared to just taking a wrong image and putting a wrong caption underneath. It's just taking different images and out of caption was just easier.
And did this research eventually lead to the founding of your company, Synthesia?
Yeah, so face to face in a sense was the precursor to Synthesia. And so Synthesia was co-founded by we were four people. We were Victor, Stefan, Lourdes, and myself. Basically, like two academics and the other two kind of with a more business background. And the idea was basically, I mean, this technology is so amazing. Let's do something with it, right? And I was always, I always wanted to make sure that research is not, in just the university environment, but I have a bit of an, I want to make sure we can create some economic value out of it too. And not necessarily for myself, but like I like this idea of creating a company out of nothing, out of thin air. You suddenly have people employed, you have products that are being sold, and people are using this technology and get it into everybody's hands. And I think this is something that appeals to me compared to just publishing a random research paper, right? So I was very keen on doing this already at the time. And yeah, so we basically in 2017 we then co-founded Synthesia. So we had a lot of discussions what we want to do and how we do it, and we actually started doing this idea of movie dubbing. What we just said, this was the key idea at the very beginning. It was very clear. Okay, look, there's movies. We have the technology. We can dub them better. Let's do it. That's it. Let's go. This was the Synthesia starting point.
Okay, and at the start of February, you tweeted that Synthesia is now valued at $4 billion and that 90% of Fortune 100 companies use it. Could you maybe tell me a bit more how it got to this point?
Yeah, I can continue maybe with where we started. Right? We wanted to do this movie dubbing, and it turned out that's actually a pretty horrible idea. So economically speaking, it was a very bad idea because what we did not realize how small that market is and how quote unquote little people are willing to pay for it. So we noticed something like we talked with the Hollywood studios, and I mean there's different numbers, but roughly on the order of magnitude, let's say somebody pays you 50 to 100K or so for the movie dubbing, and then you basically have that company, right? You have a project, you do it for a couple of months, you do one project for that amount of money, you're doing the dubbing, it's a little bit better than before, it's cool, they like it, it's cool. And then we thought, well, how many of these movies do we have? And then we realized, okay, there's like maybe 20, 30 movies a year around the size, and that was just not enough of a large market. And we very quickly realized in order to get this to work from an economic standpoint, we need to scale it up such that everybody can use it, not just the movie company. And you're thinking of what are applications where people have to create videos of people telling you stuff. And one thing we noticed is in corporate environments, there's a lot of these explanation videos. I mean, it's like corporate education in a sense. And for instance, when you go there, you have to use a tool. Somebody has to instruct you, and then you have to watch this video how this machine, for instance, works, and then you watch the next video how the next machine works, and so on. And it turns out making these videos is extremely expensive. So, and for this corporate education, that was an interesting thing because everything there was very expensive. You had a camera person coming in, had to kind of build a mobile studio in a sense, record the executive or whoever, instructor, manager to tell you how to do certain things in the company, and this was quite expensive for them. And it turns out they had a real interest of making this one fast and cheap. And so it's very interesting. We had companies like McDonald's and stuff like this before. They have so many different machines, they have so many different people working on there, and they have a pretty high fluctuation of people also. And what happened there is basically they need to do this globally, right? Around the globe, basically. And it turns out they want to just create a video, like a 20, 30, 40 seconds video that just explains something. And what we showed is if you have an avatar doing that and explaining this to you by video, it's creating more engagement than if you just show somebody text. I mean, it's kind of obvious why that happens, right? That's why we have movies and videos to begin with. But it's very clear if you do that, people will more likely follow and look at the stuff. And this is something that is much more scalable. There's more companies, obviously, than just a few movies. There's basically every company has that now, right? And they need it many, many times. So this creates an opportunity for a subscription-based model. And we could figure out now how to scale this up in a SaaS platform. So we had basically the ability to create Synthesia Studio came out then, was a couple of years later. And that one basically was then the ability for the end user or the person who wants to basically make these corporate videos, they could log into the platform, and then they could go ahead and create their videos for what they needed. And we could scale this up. And then it started skyrocketing, right? New technology came out for better videos, of course. We could do more stuff with the avatars, but the use case is still a dominant one in the sense that corporate education, how to make videos that people can use stuff, is what we realized. Yeah.
So you use your own in-house made models for all the stuff that you do with Synthesia?
By models, you mean the people, right? Or
I guess when it comes to like video generation, like what is the backbone? What is the technology behind that?
you mean the AI models?
Yeah,
you mean.
AI models.
Okay.
Sorry.
Yeah, because models, you could also mean the
Of
person who
course.
is doing the enactment. So Synthesia, at the beginning, there was no model. It was all graphics based, actually. So at the beginning, it was more this face-to-face technology. What we had at the time, there was very little AI. There was a little bit of AI, how to do the tracking of the face and reconstruction. But the generation was basically, you create a 3D model of yourself, right? But you do it very, very fast, automatically. There's an algorithm behind it, and then it re-renders it like a video character, kind of. This was the first version. And what happened is, over time, more and more of this graphic stuff got replaced by AI. Like, it was very gradual. It was like several steps in between until today, where everything is kind of a big vision transformer. And yeah, these models are driving Synthesia today, and they produce stunning quality. It's just from a real video, you cannot tell the difference anymore, and you can do it at a very high resolution as well.
When it comes to the use case, I think, yeah, it was really difficult to predict that it could be used in the context of like corporate/enterprise domain. But from what I saw on your website, you are also trying to move into that more interactive mode, where you can interact with the model. How AI model? How does that work?
Well, I mean, so the vision what we had for Synthesia for the past N years was along the line of creating AI avatars. So you can use an avatar, create a video out of it. And now the big new theme is in AI, generally speaking, is agents. So now we want to have agentic AI avatars, meaning that these avatars should also be able to do tasks in a sense. They could do interaction, they could talk with people, potentially in real time, they could interact with other avatars and stuff like that. And this is kind of the frontier in a sense, like making agent AI avatars is very thematic to where the whole AI space is going to go, right? And so think about them as individual virtual people, right? And then they can do stuff. And what Synthesia can do then, it gives it a face and it gives it an interface how to interact with it, right? And there you could imagine all kinds of applications. Like you can have, imagine you have a virtual company and you have a virtual employee, and that person could do stuff with it. And there you can have dozens of use cases around that.
All right. And I also wanted to talk to you about your other company, which you founded in May of 2025, Spatial AI. Could you tell me a bit more about that?
Yeah, so Spatial is a world models company. So in a sense, is what Synthesia has been doing for faces, Spatial wants to do for the entire world. So we want to be able to, everything you see in the real life and real world, you wanna be able to digitally replicate. So everything should look like the real world, and it should also behave and do stuff like the real world. So the interaction, physics, and stuff like this. And I believe this is the next frontier for AI, right? We have seen images and videos. Well, okay, we have text, images, and videos, and now you're gonna get a whole 3D world out of it. And the advantage of that one is we talked a little bit before about this context problem, what you have in a video, right? You can only have a certain number of frames and then you kind of lose track of what happened before. But if you're creating some spatial memory, you're creating like a whole 3D environment out of it, like that stays there. It's not gonna go away. And when you revisit it and move the camera back and look at some stuff, it's gonna look like the same. So I can give you an example. So for instance, if I wanna go ahead and create a copy of this room here, right? You imagine you take 3 or 4 photos, it's just in 2D. But what I wanna do is I wanna create a 3D model around it that I can then move the camera in any place around afterwards. And I can, for instance, load this environment into a game and then do stuff with it. I can interact with it. I can move furniture around even and stuff like that. So anything you can do in the real world, you can then do virtually. And there's a lot of applications where you need that. I mean, gaming is one of them that I just mentioned, but there's many other ones. If you want to have a kind of a 3D tour through a house or a museum, right? You can virtually and digitally look at this kind of stuff. Or if you have a house you want to redesign, you want to remodel everything. Or even more, if the house hasn't been built yet. If I'm an architect and I want to sketch a house, I can just draw it in a bunch of 2D paper, but then I get a whole like 3D scene out of it, and I can go back and forth around it. So this is kind of the idea of world models. So world models is everything you see in the real world. You want to digitally copy, mimic everything the real world can do as well.
All right. And so if you could compare Synthesia, which focuses on the who, and Spatial AI, which seems to focus on the where, the environment, which of these two was more difficult to work on?
Well, I think there's different axes of difficulty. There's the technology axis, like how hard is it to make the the AI get results that are good enough, and then there's also a commercial side, right? How can you find the right angle, in a sense, the right application use case to sell this stuff? What are you doing, right? Why does anybody care about this, basically? And for Synthesia, we had a lot of ups and downs, obviously. Like, this is just very standard for a startup. You're gonna have a lot of so the way you do a startup is basically you have an idea, you try it out, and there's a good chance the first idea doesn't work. So you have to play around. And the ability from good entrepreneurs is they just try a bunch of different stuff out very quickly and they see what sticks. And if it doesn't work, you just go ahead. And the selection bias in a startup is every successful startup, they eventually found something that works. But it's less likely that it's the first thing they ever tried. So I would generally say none of this stuff is easy. So for Synthesia, we had a starting technology, but we struggled with finding the right market for it, meaning the dubbing and stuff like this was difficult. But once we had the corporate education, I think and once that worked, then it was more or less smooth sailing, but it took quite a while to get there. For spatial, it's it's a little different actually. So the use cases, I think we know that are there. We know what you want to do, right? If you want to have an architect sell a house, they want to have a virtual stuff around it. If you want to have I don't know, like a real estate platform that sells your apartment, they want to have a virtual tour around it. If you want to have a 3D design for a game level, they want to design the game automatically and so on. So the use cases, I think, are pretty clear. I also think the technology right now to do different pieces of it, like creating a static environment and stuff like this, pretty much works, and it looks great already. So you can create static vaults. You can already do. The harder part, what's still missing, is get accurate physics in this thing. So there's a technology unknown around that one, but we believe we have a good trajectory how to get there. But I would argue the whole landscape has changed a little bit there. So the difficulty what you have right now is you have way more resources, meaning you have larger funding rounds. You can get money for AI easier. The markets are also way bigger potentially. But what you're doing has to kind of cater to multiple of these markets at the same time, because otherwise it's too small. It's not worth it in a sense doing. So you have to be very conscious about how to pick the right stuff to where you put your effort on. And for Synthesia, obviously we figure that out eventually. For spatial, we're still in the process of doing so, but we already have amazing discussions actually where people really want to use that. It's just a matter of month away right now where we ship this. And for a company that hasn't been around for basically less than a year right now, I think this is the trajectory is pretty steep how well it's going there.
And when we are on the topic of startups, the co-founder of Synthesia and the CEO, Victor Riparbelli, recently went on the Scaling Europe podcast. I don't know if you saw that. And he said the following: I always used to say, in Europe, nobody knows anyone who made any money of working in a startup. In the US, everybody knows someone who made $1 million by being early somewhere. And we need more of those stories to both inspire the next generation of entrepreneurs. We need those stories to inspire people to want to work in the startup land. So, what is your take on the startup culture in Europe versus the United States?
I mean, I have mainly two references for that. I was at Stanford for 4 years, so I was living in Palo Alto, which is kind of the core of Silicon Valley. It's the Bay Area. It's where a lot of the big tech companies are and startups are. And I've seen the ecosystem in London specifically, where Synthesia has its headquarters, and also Spatial is. Half of the people are basically in London, half of the people are here in Munich, and I've seen the Munich ecosystem, and I don't think I actually tend to think less about regionally, if I'm honest, because I think all of these AI technologies right now, they're global. Like, I don't think you can win the startup game by just saying, "Oh, I'm the champ in a certain small region." And of course, Europe is a big region, but I don't think you can win with just being that. I think it's not. Nobody is gonna take an inferior model for patriotism, I think that's unlikely that this is going to happen. So I don't believe in that. So I always think about this as a global enterprise. And I think that's the way this is going to evolve. There's obviously geopolitics and stuff like this around. But if you're comparing the different hubs, of course, Silicon Valley is by far the biggest, by far. But you have other challenges there. It's not like you can just do a startup from scratch. It's also you have to compete with all the other tech companies. Whereas here in Europe, I think, especially in Munich, from a founder perspective, we have a lot of advantage. We have a lot of great people from the universities, and we get the top tech talent in order to build what we want. So from an engineering perspective, I think we are doing actually really well. Where in Germany/Europe we are not doing well is the entrepreneurial spirit. Basically, people they're very resistant to change on average, and they're very hesitant to do a company to begin with, because they still feel there's some risk associated with it. And I disagree with that, actually. I don't think there's a risk. I think there's just upside right now, actually. You can just do it if you're doing well. then you can create a lot of value out of nothing. And at the moment, it's almost a no-brainer to do it. So I think it's more cultural problem that we have than a ecosystem problem, if that makes sense. The, in Munich specifically, we have an advantage that it's so international, specifically on the TUM campus here. I mean, we have more than 50% foreign master students in the computer science studies here, right? And that is, I think, a massive difference. And I mean, this is, you might say, well, okay, so Germany couldn't do it alone, but it's the same thing in Silicon Valley. They're all immigrants. There's very few native that actually went there. They're all like immigrants. They're all coming from all over the world. They go there and believe they have the best opportunity. And I believe if we want to be successful in the space, we have to do the same thing. We have to get the best people around the world and show them, hey, we can do really good stuff. We show them the environment is great, and Munich obviously is a fantastic city to live in from a just living perspective. So from that perspective, I think we should stop whining about it and just do it. I mean, I think we should just do our stuff. So I never thought about this was a pro, con, or whatever. I'm just trying to play my cards well, and I think so far we've been pretty successful with it, and I hope we can contribute to having another success story.
And I just wanted to ask you one more thing. So, do you not fear some kind of a plateau that will eventually come when it comes to the expectations for those AI models, given text, video, images, to always improve and improve exponentially, and that this plateau will eventually come? What will happen then?
I mean, from a practical standpoint on a day-to-day, I don't see it happening anytime soon because the gradient of how fast progress is being made is just it's just insane. I don't think I have ever. I mean, you can look up technology adaptation if you go back in history, right? How long it took to develop something, how long it took for people to use it and stuff like this. And so far, AI in a sense has been the fastest ever. You have global distribution with internet basically. It's instant. You have a new model, it rolls out, everybody's going to use it. So, and you also see how quickly new models are coming out and how much better they are than the predecessors, right? And I actually saw it more accelerating than plateauing actually. So I think the stuff at the moment is just moving so much faster than it used to be before in terms of technical capability. But there's a second axis to it, obviously, like who's gonna care about it? Like, how is the economic value being created from that, right? I mean, for instance, a lot of people cite the dot-com bubble as a um, as a warning sign in a sense. Okay, people realized, okay, economy can go sideways, but that was very different because they have people having websites without any income, right? They had no revenue. But with AI, it's very different. I mean, we're having companies that's starting out and like after a year or 2 years, they have like millions and millions of dollars of annual revenue. And that is something where, I don't believe that there's an AI bubble or any plateau anytime soon because I just see more and more people using that. So you still, of course, have a significant chunk of the population who are not that into it. I mean, like they might resist it for various reasons because there's a big shift in society happening. But it's very obvious that these AI tools, they're gonna create so much more productivity and you can do more stuff with it. And eventually everybody will have to work less. It's kind of an insane thing. And if I'm extrapolating the next big things that will come out next, you're gonna have, okay, so we talked a lot about generative AI for like visual content. Maybe, there's text, there's coding agents, all this kind of stuff. But there's gonna be a big physical implication when we can use this kind of stuff to train robots well. Like we were gonna have robots for your home use very soon. They're not going to do everything at the same time, right? We have some robots. We have a lawnmower, and we have maybe I don't know, a Roomba cleaning robot or something like this. But you're going to have a lot more of this kind of stuff doing chores in your household. And this is not going to happen overnight. It's not going to happen tomorrow or next year even. But this will happen. And it's very obvious what the path there will look like. And there's so many of these paths. If only a few of them will be successful, you're gonna see so much economic value created from it. So I don't see any plateau anytime soon there. And that I think is why I'm not so worried about the tech progress because you see it at the moment that this is a reality. The bigger question is more like how we shape society around it. Basically, this is maybe one thing that worries me. Well, doesn't worry me, but it's a thing we have to consider and how to deal with it, right?
Okay. And seeing how we are almost out of time, I just wanted to ask you one last question. Uh, so, with so much progress going on, and as you just said, people will work less in the future, do you think there are some tasks which shouldn't be designated to artificial intelligence?
So I generally don't think that AIs are gonna completely take over a lot of tasks. Actually, that's maybe a misconception. I think AI tools are a multiplier force, but they're not a replacement. And I can give a few examples. Like if you're talking about like medical imaging, radiology, and stuff like that, if you're thinking about it, everybody predicted like almost 10 years ago, oh, we don't need radiologists anymore. Don't do radiologist. Don't become a radiologist. And what happened is we just took a lot of more images like MRIs, CTs, stuff like this. We took a lot more of these ones than we ever took before, and AI helped us to understand them better. We got better quality outputs. So and I think AI is not gonna suddenly say, "Oh, we don't need this kind of stuff anymore." We're just gonna use it to get way better at it. And so in a sense, I don't think AI is going to replace the radiologist, but the radiologist will have to use it to be more productive. And the same thing I feel about many other areas right now too. So the current big discussion is, do we still need software development, right? Everybody talks about, oh, AI can do software development. I can give a prompt and it gives me out with my coding engine and gives some stuff out. And I don't think it's the same thing there. You still need the logic behind it in the sense of saying like, oh, what do you actually want to do? You need a person to design this stuff around it. And then, yeah, it's going to be much, much faster. But I don't think there's an AI just suddenly having the intent, I want to build a random web browser or something like this. It's just not going to happen. And, and this is why, yes, there will be a lot of things that will be like mundane tasks will be automated, but at the moment, I think they're mostly supporting users in a sense, for the most part. They will, for sure, there's gonna be a lot of, there's gonna be job displacement. There's no sugarcoating around that one. There will be some things will be more important, some things will be less important, but I don't think we just suddenly run out of stuff to do. I think we will just can do more stuff and better. And the medical one was one example. I think you can just do more medical imaging. You just can do better examination, do better healthcare. Like it's not that our doctors they're running out of work, right? We need to help them and give them better tools to do stuff like this. And the same thing, I could go through every single example. I could see that, right? So within these respective areas, you're gonna see some stuff that becomes more important than other stuff, and other part comes away. But I don't think the global need to innovate and do stuff around it and execute is going to go away, right? Necessarily. So I think AI will be a key tool for everybody there, but I don't think it's necessarily going to just replace entire things. So this is, I think, this is important to understand.
Ladies and gentlemen, Professor Matthias Niessner, thank you so much, Professor, for your time and your insights.
Cool. Thanks a lot for having me.